Assalamualaikum warahmatullahi wabarakatuh. Thanks for the chance that given to us. Now we would like to present about performance assessment design on Ethnomathematics-based PJBL learning for students. Let us introduce ourselves. We are Himmatul, Ulya, and Ratri Rahayu from Universitas Muria Kudus, and Khalisa Dija and Abdul Qohar from Universitas Negeri Malang. We will explain why this research is so important. This research was motivated by learning expectations of the 21st century are the development of critical thinking, collaboration, creativity, and communication skills. Mathematical thinking process skills cover all of these aspects. Based on preliminary research, students are not yet skilled in determining pattern when solving a problem and communicating the problem into mathematical ideas. Their poor mathematical thinking process skills are caused by their inability to understand problems, so that it's difficult for them to connect concepts used supposedly for solving the problems. These problems should be overcome by involving students in a learning process that is related to real-life problems. The PJBL or project-based learning can be used as a solution because it utilizes projects that involve students in knowledge and skill transfer to a discovery process with a series of questions arranged in assignment. A proper authentic assessment to measure process skill is performance assessment. Performance assessment requires students to actively carry out complex assessment. Therefore, a learning that can be integrated with performance assessment is needed. Innovation in performance assessment is needed to measure mathematical thinking process skills that are integrated into ethnomathematics-based PJBL learning. Objectives of this research are analyze students' mathematical thinking process skills. Number 2, discover students' expectation on the learning process and assessment in ethnomathematical learning. And then produce a performance assessment model designed on ethnomathematics-based PJBL learning to measure students' mathematical thinking process skill. And then the methods. This research used a qualitative research approach. And then the subject in this study were 32 students of the 6th semester of the mathematics education program at Universitas Muria Kudus. Data were obtained from literature review and field surveys, which included documentation studies, questionnaire, and interviews. Then the data were analyzed descriptively and data triangulation was carried out with the following stages: reduction, data presentation, and conclusion. The result of this research are students' mathematical problem-solving skills. The descriptive analysis of the data in this research was used to present data on students' mathematical thinking process skill for each indicator. The data on students' mathematical thinking process skill that are described according to indicators of mathematical thinking process skills are presented in this table. Based on table 1, students achieve indicators of determining pattern and draw conclusion by 47.86%. And then communicate problems into mathematical ideas by 57.93%. and performing mathematical calculation by 59.14%. This shows that indicators of students' mathematical thinking process skills have not been achieved well, indicating that students' mathematical thinking process skills are not optimal because they only reach an average value of 54.14%. The result of students' expectation on the learning process and assessment in ethnomathematical learning are students' interest in being involved in learning, interest in a learning that is associated with real life or culture problems to improve their mathematical thinking process skill, interest in regional excellence, interest in project activities that are carried out in an associative with their surrounding environment and culture, interest in realistic and authentic assessment that show performance of each individual. And the result of focus group discussion in order to create a design draft of an assessment model for learning that is in accordance with the need in the field, FGD was conducted and attended by assessment experts, mathematics learning experts, and ethnomathematics experts. Through the discussion, the opinions were obtained and used for elaborating the design of assessment model in learning so it could improve student mathematical thinking process skill. Feedback from expert is summarized as follows. Number one, the model of performance assessment in ethnomathematics-based PJBL learning is used to develop students' mathematical thinking process skill. Number two, the performance assessment on ethnomathematics-based PJBL learning is associated with culture in the East Coast region, including Semarang, Demak, Jepara, Kudus, Pati, and Rembang. And then the design of the performance assessment model in ethnomathematics-based PJBL learning contains objective, components, instrument, syntax, and a model guideline. And the last rubrics are developed to measure mathematical thinking process skill through performance assessment in ethnomathematics-based PJBL learning. The design of performance assessment model in ethnomathematics-based PJBL learning. Number one, the results of the preliminary study and the FGD that were carried out with experts were used as a reference and basis in developing a draft design for our performance assessment model on mathematics-based PJBL learning. The research product that was produced is in form of a performance assessment model on a mathematical-based PJBL learning. The model includes objective, components, instruments, syntax, and a model guideline. The model is applied in ethnomathematics-based PJBL learning by utilizing elements of regional culture in interesting and fun activities. The performance assessment model is applied in mathematical-based PJBL learning. It includes a model guideline that consists of an introduction, the theory of performance assessment, the theory of ethnomathematics-based PJBL, the theory of mathematical thinking process skills, performance assessment tools to measure mathematical thinking process skills, and guidelines for implementing performance assessment based on ethnomathematics. Based on the research result, it can be concluded that
Students' mathematical thinking process skills are not
optimal because its mean value is 54.14%. Students expect to be involved in an active learning process that is related to real-life events and based on culture and includes an assessment that shows performance of each individual. And the last, a design of a performance assessment model in ethnomathematics-based PJBL learning, which includes objective, components, instrument, syntax, and a model guideline is produced. The contribution of this research is that it can be used as a preliminary research in developing a performance assessment models in mathematics-based PJBL learning so that the produced model will be valid, practical, and effective. On this occasion, we would like to thank the Ministry of Education, Culture, Research and Technology, the Directorate General of Higher Education for funding this research. Thank you very much for your great attention. Wassalamualaikum warahmatullahi wabarakatuh.